Gas metal arc welding, GMAW, is also called MIG, metal inert gas welding, or MAG, metal active gas welding. It uses an electric arc that is established between the consumable solid wire electrode and the workpiece as an energy source. A shielding gas is supplied through the welding gun to provide a shielding blanket to protect the weld from atmospheric contamination. GMAW produces high-quality welds at high speed with limited post-weld cleaning. Therefore, it is widely used by high-production metal joining industries like automotive companies. In 1948, gas metal arc welding, or GMAW, was introduced. In the beginning, the GMAW process was used to weld aluminum using argon as the shielding gas. Therefore, another name for GMAW is MIG, metal inert gas. The subsequent development of the process included applications for a broader range of materials, which resulted in the use of reactive gases like carbon dioxide and oxygen. This led to the formal acceptance of the name of GMAW. In modern days, the GMAW process can be semi-automatic or automatic. There are three primary variations of metal transfer in GMAW: the short-circuiting transfer, the globular transfer, and the spray transfer. They differ in the way of transferring the metal from the electrode wire to the workpiece. Each of the transfer method has distinct properties and corresponding advantages and limitations. Short-circuit or short-arc gas metal arc welding, or GMAWS, is the most common process used with GMA welding. It is obtained by using the lowest voltage range for the given electrode diameter. Using the 0.045-inch E70S wire with 100% carbon dioxide, the voltage range for short-circuit transfer is from 18.5 volts to 24 volts. The molten wire transfers directly to the base metal to form a weld pool. You can see from this movie that the tip of the wire is buried halfway in the melted puddle. If you do it right, short-circuit transfer gives a crackling or bacon frying sound, like the movie sounds. A shielding gas mixture of 25% carbon dioxide and 75% argon produces a desirable weld profile. The resultant weld appears to be highly crowned, like a cold bead. Advantages of short-circuit GMAW include: 1. Low spatter. 2. Easy to use. And 3. All-position welding on thin materials. Disadvantages of short-circuit GMAW include: 1. Does not produce enough heat to weld materials that are thicker than a quarter inch. And 2. Easily produces lack of fusion defects. The recommended wire diameter to be used in the short-circuit variation include: 1. 0.023 inch. 2. 0.030 inch. 3. 0.035 inch. And 0.045 inch. This transfer mode can be used in: 1. Low carbon steel. 2. Low alloy steel. And stainless steel with thickness ranging from 0.5 mm or 0.02 inch to 2.6 mm or 0.1 inch. Globular transfer gas metal arc welding is obtained by using the middle voltage range for the given electrode diameter. Using the 0.045-inch E70S wire with 100% carbon dioxide, the voltage range for globular transfer is from 26 volts to 28 volts. The molten wire grows in size until its diameter reaches 2 or 3 times the diameter of the wire before it collapses and transfers to the arc. You can see from this movie that the tip of the wire has molten metal that drops down onto the weld puddle. If you do it right, globular transfer sounds like water spitting in a hot skillet. A shielding gas mixture of 25% carbon dioxide and 75% argon will produce a more desirable weld profile. Advantages of globular transfer include: 1. All-position welding. 2. Can be used with inexpensive carbon dioxide shielding gas. Disadvantages of it include 1. Creating great deal of spatter. 2. Lack of fusion defects. 3. Being inefficient because the wire used is a lot more than the weld deposited. Globular transfer mode of gas metal arc welding is used to weld on sheet metal. The spray transfer method of the gas metal arc welding is obtained by using the highest voltage range for the given electrode diameter. Using the 0.045-inch E70S wire with 100% carbon dioxide, the voltage range for spray transfer is from 28 volts to 30 volts. The molten wire forms as fine droplets and travel at a high speed directly through the arc stream to the weld pool. You can see from this movie that there is a cone-shaped glow at the tip of the wire. If you do it right, spray transfer gives a humming sound. A shielding gas mixture of 5% carbon dioxide and 95% argon will produce a more desirable weld profile. Advantages of spray transfer mode include 1. Spatter-free. 2. All-position welding. Disadvantages of it include 1. Requires argon-rich shielding gas mixtures. 2. Is only suitable on metals that are thicker than a 1/4 inch. Spray transfer mode of gas metal arc welding is used to weld on thick metals. Next we will be talking about the common terms used in gas metal arc welding. Electrode core wire is the electrode in the form of wire. This wire melts to become part of the weld, hence the wire is considered as part of the consumables of the GMAW process. Deposition rate is the mass of weld deposited, in kilogram or pound. Per unit time, hour. Deposition efficiency is the ratio of mass of weld deposited to the mass of electrode consumed. In other words, the process is more efficient when less material is wasted. In theory, gas metal arc welding has deposition efficiency range of 80%. The loss of deposition efficiency is due to the presence of the impurities which need to be removed after welding. Weld spatter, which does not become part of the weld, contributes to the deposition efficiency loss. Furthermore, when the wire reaches the end of a spool, about 15 to 25 feet of wire has to be thrown away, which also adds to the deposition inefficiency. Shown here is the deposition efficiency of the common welding processes. Notice that gas-shielded processes like GTAW and GMAW have higher deposition efficiency than self-shielded processes like FCAWS and SMA. Root pass. The first bead or layer of a weld. Root opening. The gap or distance at the root between parts to be joined by a groove weld. Electrode stick-out is the length of unmelted electrode extending beyond the end of the contact tube or nozzle during welding. Increasing the electrode extension increases the resistance heating of the electrode, which preheats the electrode and lowers the voltage drop across the arc. Using a longer electrode extension also protects the nozzle tip by moving the arc away from it. The beads that are showing are the beads that are visible on the face of the weld. This is also referred to as the welding cap. Gun angle is the angle between the workpiece and where the gun is held. In this figure, the gun angle is 55 degrees to the left plate for the third bead of the weld. Review questions. What year was gas metal arc welding, GMAW? Right answer. What gases are considered reactive gases for GMAW? Right answer. What are the advantages to GMAW short-circuiting transfer? Check all that apply. Right answer. What are the disadvantages to GMAW globular transfer? Check, right answer. What are the advantages to GMAW spray transfer? Check, right answer. Which transfer mode of GMAW welding is suitable for use on thick metals? Right answer. What items are considered part of the consumables of the GMAW process? Right answer. Which welding processes have deposition efficiency higher than 90%? Check all that apply. Right answer. 9. Match the term with its definition. Right answer.